solid is going to be the number of cubic units contained inside of its interior. So a cubic unit is like an inch by inch by inch would be an inch cubed, right? So finding the volume of a cube we just talked about, if you have the same sides, right, if you have S, S, and S, we know the volume of anything that looks like this is length times width times height. You guys have been doing that probably since elementary school. So this ends up being S to the 3, S cubed. So the volume congruence postulate is very easy. It just says if two polyhedra are congruent, then they must have the same volume. And then the volume addition says if I have the volume of a solid is the sum of the volumes of all its non-overlapping parts. So I could have something like the volume of a cube, and then on top of it, maybe I have a pyramid. I could find the volume of the cube plus the volume of the pyramid, and I could put them together. Easy enough? All right. So there are really only two equations that you need to know. The first one is for the volume of anything that has two bases. So something that has two bases would be something like a prism. So imagine I have a square-based prism. Something, oh, totally missed it. That's rough. All right, something like that. Or I could have maybe a hexagonal base. Do you guys remember the pictures that look like this? Try to sketch that super fast. It's a struggle. I'm struggling. Okay, that would be something where it's a prism. Or I could have a cylinder. So a cylinder is something that has like two circles, right? All right, so its equation for a prism or cylinder, so two bases, ends up being V is equal to big B times H. Okay, but you have to be very careful, and I told you about this the other day. Like, we get very, very particular about capital versus lowercase letters. So when I see a big B, that means the area of the base. It doesn't just mean like a length, like 7 inches. It would be like 49 inches squared, right? So this is the area of the base. Okay, and we just did that little activity with the water. Thank you, Isabella, for loaning your water. And we said that the volume of a pyramid or cone, so if it has one base, how is it different? How many of those fit inside of the prism or cylinder? 3 of them. So it's 1/3 the volume of whatever we had before, right? So what we're saying is if we have a cone, that cone, it takes 3 of those to fit inside the cylinder with the same height. Okay, so there's 3 of those cones shapes, the water filling each of those cones. You have to have 3 cones fitting inside of the cylinder with the same height and same area of the base. Okay, two equations, that's all we have. That's it. The side cubed is actually already there. It's the area of the base, which would be a square, x by x, and then times the height, which is still x, or s if you want to use s. So number 1 says, find the volume of the right prism shown below. So I could do this as area of the base times the height, or I could actually do volume equals length times width times height if we want. Okay, the area of our base is going to be this right here. Our base is 5 times 8, and then the area of the height is going to be 2. So we get 40 times 2, which is 80 cubic inches. Is this the easiest lesson ever so far? Yeah. Have you done this before? Yes. I'm guessing all of you have, yeah. So it does get harder, obviously, but we're starting out with the basics. All right, so find the volume of the right cylinder. So in this case, the area of the base is a circle. How do I find the area of a circle?
Pi r squared.
Yeah, pi r squared. So I'm going to do pi times, what's r?
4.
Yep, so pi times 4 squared, which is 16 pi. That's just big B. So if I want my volume, I do my area of my base multiplied by my height. So my area of my base was 16 pi multiplied by the height, which is 15. So I do 16 times 15, and I get 240. So it's 240 pi, and my units, since it's a volume, is cubic feet. Make sense? So when we talk about something like cubic feet, like I was saying, it's like if I had a cube that was 1 foot by 1 foot by 1 foot, I would be able to fit 240 times pi, which is like 753 something. I would be able to fit 753 of those little cubes inside of that. Does that make sense? That's what we're talking about. That's volume. All right, so find the volume of the entire solid. What do you guys think we do in this example? Yeah?
Do the two prisms separate and then add the volumes
Yep.
together?
Exactly, and that's this theorem, which we talked about, which is the volume addition postulate. You just find the individual volumes and you add them together. Okay, so the first one, so let's say we talk about this small one up here on the top. Okay, do we know its length, width, and height?
Yes.
Yeah, so you could write length times width times height, or you could say area of the base. The area of the base would be 3 times 10, right? 10 times 3 there. And then you can multiply by the height, which is 5. Okay, so if you prefer to write it as 3 times 10 times 5, like without any parentheses, that's fine. Okay, the next one.
Isn't it 150 altogether?
Mm-hmm. The next one has an area of a base of 17 times 5, and its height is 10. So Cam's saying he already found 3 times 10 times 5, which was 150. How about the 17 times 5 times 10? Yes, good job. So if I add those together, oh, what a nice number. Isn't that so pleasing? 1,000 cubic inches. And that's our answer. We add them together, yep. Because you find the volume of one and the volume of the other. It's kind of like we filled them with water, like with Isabella's water bottle, right? We'd have a total of 1,000 cubic inches. All right, so this is where I told you it gets harder. It's not just as easy as you guys learned in elementary school. Don't you wish everything was just like, oh, let's review 5th grade? That's not what we're doing. All right, so number 4. So it says find the volume of the right hexagonal prism. So on this one, ooh, I said prism. That should say pyramid, shouldn't it? My picture is a pyramid. So in order to find the volume of a pyramid, I do 1/3 the area of the base times the height, because there's only one base. I don't have 2 parallel bases. It's not a prism. So I need to figure out the area of the base. Okay, and this is where our geometry that we've learned before comes into play. So I have 6 along here. And then I want to know what the area of this base is. Do you guys remember for a hexagon? If I go all the way around, there'd be 6 of those little pizza slices, I guess. Each of them is going to be 60 degrees, I agree. So then if you break it down the middle, it's going to be 30, 60, and 90. So that 6 that we had before that went from here to here is really just 3 right there. So we have a 3 here, and we have a 30, 60, 90 triangle. Do you guys remember the word for this line right here? What's that called? Geometry definition time. Apothem. And the apothem, any idea how long that is? Close. 3 root 3, right? So 3 radical 3 or 3 root 3. Okay, because we had 3 along the bottom. So if I want to get the area of this whole thing, Colin, you with me?
Yep.
The area of this base ends up being 1/2 perimeter times apothem. Or you could find the area of one of these triangles and say, oh, I'm going to take 6 of those triangles, multiply by 6. So we end up getting 1/2. The perimeter would be 36. The apothem we said was 3 root 3. So if we multiply it out, I have half of 36 is 18. 18 times 3 is 54. So I have 54 root 3 is my area of my base. Ian, do you have some paper somewhere, a pencil? Or not Ian, Colin. It's between the two of you. I keep looking at both of you.
Yeah, I'm on task. So.
Oh, man. You are. Good job, Ian. So proud. All right, so my base is going to be 54 root 3. That's the area of the base. And my height is going to be, ooh, another hard question. So the height of a pyramid always starts in the middle and goes up. Okay, that's not what this is pointing towards. This is actually pointing, this 9 is right there. So that distance is 9 right there. Rhett, I think you're thinking about it. Are the wheels spinning? Are you trying to think about how to find this h, this height?
No, you just make it to right triangle, like say take the apothem, whatever, like that.
Not quite the apothem, but this distance right here.
Oh, yeah.
Right?
Okay,
which ends up being 6, which is the same as the side length, right? Do you guys see why it's 6? Because we had 3 root 3, and then the hypotenuse would be 6. Okay, so he's saying take that, and this ends up being a right triangle. I agree with that. Do you guys agree? So he's saying you got the height of the triangle, you got 9 here, and this ends up being 6 along the bottom. So how do we get h? Yeah, Pythagorean theorem. So I'm going to say h squared equals, or no, h squared plus 6 squared equals 9 squared. So I'm going to have 81 minus the 36. So I end up getting h squared is equal to 45. What's the square root of 45? Well, how would I write that? 3 root 5. You guys are on it. Look at you. I feel like you're ready for the final exam right now. Like I should just give it to you.
No.
Wouldn't that be nice? And then 2 weeks we'll just sit here and relax and do nothing. All right, so what's our volume then? So let's start trying to combine our terms. So I have 1/2, or 1/3 and 54. So let's do 54 divided by 3. So that's 18. And then times 3 is 54. Why did I do it that way? Shouldn't I have just done 1/3 and 3? That would have been really smart. All right, anyway, so what else do I have? I have the square root of 3 and square root of 5. So what do I get?
Square root of 15.
Square root of 15, that's our volume. If you wanted to find it as a decimal, you could, but that's fine, you can leave it like that. But as a decimal, it would be around 209.141. Units, we don't have any units. So you could write units cubed if you want to, but we'll just leave it like that. Make sense? Could you do that on your own?
No.
No. Do you think after you do your homework, maybe you could?
Maybe.
We'll see. All right, so number 5. So use the measurements given to solve for x in the rectangular prism with a volume of 134.75. So now I'm going backwards. I have the volume. I want to find x. How do I set up this equation? 11 times x squared equals 134.75. So we divide by 11, and I get x squared is equal to 12.25. Then what?
Square root.
Square root. Do I write plus or minus? Can x be negative? No. So it's 3.5 anyway. So x is 3.5 centimeters. Still okay? Okay, let's try a couple more. Okay, this one. So number 6, if a right cylinder has a volume of 277 cubic feet and a height of 5 feet, what is the diameter? So let's draw a picture. So a right cylinder. Now, when I use the word right, it's not really a big deal. It just means that it's a straight up and down cylinder. It's not like a, have you seen cylinders where they're like the Leaning Tower of Pisa? That's a oblique cylinder is what we'd call it. It's something that's leaning. All right, so a right just means it's straight up and down. All right, we're not going to deal with the oblique ones. We're just going to do these right ones. Okay, and it has a height of 5 feet. What is the diameter? So we want D. So we know that a cylinder has equation volume is equal to, do I do 1/3 area of the base times the height? Or area of the base times the height? Oh, you guessed wrong. Man, you got a 50-50 chance there, Joseph. All right, why is it not 1/3? The 1/3 is the ones that, they're the ones that go to a point at the top, like a pyramid or a cone, right? The ones that have 2 bases, see how this has 2 bases? 2 parallel bases? This is going to be area of the base times the height. Now, what if it was a cylinder that was like on its side? What's the base then? Yeah, it's still these circles, right? So it can be on its side, but it's just the items that are like parallel to each other. Those are the bases. All right, so we're going to do the area of a base is a circle, pi r squared times h, right? So our volume was given to us. It's 277. Our r we don't know, but our height we know is 5. So we're going to solve for r, and let's go ahead and do it in decimals. So go ahead and keep your get your calculator out and keep the numbers in your calculator as you go. So like I'm going to do 277 divided by 5, and I get 55.4. Can I take the square root yet, though? No, I need to divide by pi, right? So I do 17.634 is equal to r squared. Now I take the square root. Now I kept that number in my calculator because I had rounded. So I'm going to say r is equal to 4.199. So then how do I get the diameter? I multiply by 2, right? So I keep that number in my calculator and I do times 2. So I get 8.399. Units? Feet.
Feet.
Yep. So feet because it's like a length, not an area. Okay. You got it? Did you keep all those numbers in your calculator? You don't even have your calculator out, Charlie. Oh, it is. Yay, good. I'm just hating on that table, and you guys are on it. You are, machine. Yeah. I did. Yeah, I found the square root. Yep, and that was r, and then you double it to get the diameter. So it's not r squared as diameter, it's 2r as diameter. Remember that? Okay. All right, so number 7. All right, so let's find the volume of this right square base pyramid on the right. Or find the volume of the, yeah, okay. The slant height. Okay, what do you guys think I mean by slant height? That's weird.
Like the height of one of those diagonals.
Yeah, this height right here is 5. That's called the slant height. Because it's the height along one of the slanted sides. It's like the height of a triangle, but that triangular face. Oh man, this is gonna be rough. Do you guys want to try it first?
No.
Are you? It's just May and you're just done, huh?
I've seen senioritis.
You're a sophomore, so having senioritis, that's gonna be an issue.
Can't you just take the triangle and kind of stand it up? Like, can't you just find it as if it was
Yeah, you can find like the area of one of those sides, which we're actually gonna do when we talk about surface area, right? But we're on volume right now. You're already going on to the next section. You're super excited. All right, so we want to know the area of the base. What type of base do we have?
Square.
Square? Are you sure it's a square? What about a rectangle?
Oh.
It says square base pyramid, right? So it's a square. So it's 6 times 6 for the area of the base, right? So it's a 6 there. And we want our height, but our height is always straight down the middle to the center of that. Okay, so here's what we're going to do. We have this 90-degree angle in there. And we have 5. We want to know h. Do you guys know this distance along here? 3. Why do you say that? It's half of 6, right? Can we get the height then? Some of you guys might know it already. It's a 3, 4, 5 right triangle, so we get h is equal to 4. 3 squared plus 4 squared is equal to 5 squared. So we have a 4 in there. So our volume is going to be 36 times 4. If I'm multiplying something by 4 and I don't have a calculator, I double and double again. 36 times 2 is 72, times 2 again is 144. So it's 144 millimeters cubed. So cubic millimeters. That's our answer. Yes. Oh, I forgot my 1/3. You're right. So sad. All right, it is 1/3 because it's not a... It doesn't have one base. It has 2. It has one base. Oh, sorry. Did I say it has 2? It doesn't have 2. It has one base. So we get 48 millimeters squared. Jacob got me. He gets a bonus point. Darn. I was on a roll, too. All right. Yeah.
Is it still millimeters cubed?
Ah! Kushal got me, too. Did I say cubed and I wrote squared? Don't you hate that? All right, next up. All right, number 8. So find the volume of the right cone below. All right, I feel like you guys can try these ones. So try number 8 and try number 9 and see what you get. All right, so number 8. So you should have the volume is equal to 1/3 the area of the base times the height. Your area of your base is pi times r squared. What's r in this instance? 3.1. So we do pi times 3.1 squared. And then the height is going to be 8.4. So I would do 3.1 squared. I'd multiply by 8.4. And then I multiply by 1/3, which you can do on your calculator, or you can divide by 3 is the same thing. So if I divide by 3. So I get like 26.908, but I still have that pi. So Isabel asked a good question. She said, would you leave it? Like, do you want it in terms of pi? Typically, if something's a decimal times pi, I just multiply pi in, you know, because it's a decimal anyway, so it doesn't really look very, like, precise the way it is. But if something was like 5 pi, I leave it as 5 pi. It just looks prettier to me than finding the weird approximation. So we end up getting that it's 84.534 cubic inches. Did you have that?
I got 86.
I think 533.
Did you use the pi button on your calculator, or did you use 3.14?
I used the pi button, but then I rounded this.
Don't round in the middle. Yeah.
I put 53339.
Oh, yes. You could do that as well. 8 decimal points. Yes.
If we just round it to 5, is 0.5, is that alright?
Yeah, that's fine, but usually, remember, I do like 3 decimals. It's
Use a
kind of my
Band-Aid
thing.
or drink
That's
it
what I
right
do.
there.
Yeah, you can go ask. All right, number 9. So using the given measurements to solve, for the radius x. So in this case, it's still this 1/3 area of the base times the height. And our area of our base is pi r squared, right? So I'm not going to write r, I'm going to write x. So I'm going to do pi x squared. And then my height is 26. And I want my total volume to be 2,000. Did you feel pretty good about this one? The first thing I personally would do would be get rid of that 1/3. How can I get rid of the 1/3?
Multiply the 3 in.
Yeah, multiply the 3 to the other side, right? So is that what you mean?
Yeah.
Like multiply it over. So I get 6,000, and I'm going to have 26 times pi times x squared. Okay. So you can divide by 26 and then divide by pi, or you could do it together. You could divide by 26 pi, but be very, very careful if you do this. Did some of you guys do this?
Yes.
You want to put parentheses around the 26 pi. Because otherwise your calculator will do divided by 26, and then it will take that answer and it will multiply by pi. Okay. So we end up getting x squared is equal to 73.456. So when we take the square root, we should get 8.571. Did you guys have that as your number? Good, awesome. Units? Feet, yep. All right, last little bit here.
Wait, can you go back?
So this is definitely something that's applicable to real life volume, right? For instance, I spent my Mother's Day yesterday. You know what I did? I mulched my entire garden.
Happy Mother's Day.
And then I woke up this morning and I felt like I was 85 years old. I was like, oh, I can't move. But as a math teacher, you would think that I would approximate the amount of mulch that I need. I didn't. I just went for it and got some bags. And then guess what? I went back to Lowe's twice to get more bags. So I was thinking as I was mulching, I was like, I really should have figured out how much mulch I need. And I should have measured my garden and then multiplied by like the thickness of the mulch that I want to figure out how many cubic feet of mulch I need. But I did not do that.
Yeah, the people Lowe's are this person.
I know, they were like, oh my gosh, this lady on Mother's Day, jeez.
Yeah.
All right, so number 10. So coolant is poured through a funnel in a radiator at a rate of 198 millimeters cubed per second. Coolant flows out at 60 millimeters per second. So if we have coolant going in and coolant going out, how much am I gaining per second? I have coolant in and coolant out. I could do my 198 minus the 60. This is how much I'm gaining, 138. So it says estimate the time it will take for it to overflow. Think about how I would do this. I want to find how many seconds it takes for it to overflow. How do I find that? After 1 second, I have 138 cubic millimeters. After 2 seconds, I have 2 times 138. After 3 seconds, 2,000 divided by 138. That finds the number of seconds. I end up getting 14.493 seconds. That's how long it takes. The next one is the same thing, only you don't have the volume. You have to find the volume first, and then you have to think about how many seconds it takes. All right, I actually didn't put any of those on your homework. Why did I not? Missed opportunity. All right, so let me pass out your homework.